Welcome to The Explainer. Today, we're going to tackle a huge cosmic mystery. What's really behind Earth's ice ages? It turns out the answer isn't really on our planet at all. It's written in the stars.
All right, so let's get right into it. If you look back through Earth's history, for millions of years, there's this rhythm. Our planet's climate just keeps swinging back and forth, from these intense, deep freezes to really warm periods. The big question has always been, what's pulling the strings?
And here's the thing. It's not random at all. It's like clockwork. Over just the last million years, we've seen about 10 of these major cycles. It's this incredibly consistent pulse, this beat that tells the massive ice sheets when to advance and when to retreat. So for scientists, this was a massive puzzle, a real cosmic whodunit. What kind of force is powerful enough to be the planet's pacemaker, to reliably push Earth into an ice age and then just as reliably pull it back out again? Well, the answer, or at least the key, came from this brilliant Serbian mathematician, Milankovitch, way back in the 1920s. He had this amazing idea, this light bulb moment. He realized everyone was looking in the wrong place. The answer wasn't on Earth, it was in how Earth moves through space. So Milankovitch pointed to three sort of long-term wobbles and shifts in our orbit. And you can think of them like three giant gears in a celestial clock. They all turn at different speeds, but together they control how much sunlight hits different parts of our planet, and that is what drives our climate over these immense timescales. Okay, so gear number one is something called obliquity. It's just a fancy word for the planet's tilt. The reason we have seasons? Well, that tilt isn't fixed. It actually rocks back and forth over a 41,000-year cycle. When the tilt is bigger, you get more extreme seasons, really hot summers, really cold winters. And when the tilt is smaller, things get a lot milder. Next up, gear number two, eccentricity. This is all about the shape of our orbit around the sun. It's not a perfect circle, it's more of an oval. And that oval shape actually stretches and then gets more circular again. This happens over a really long 100,000-year cycle. And what that does is it changes our distance from the sun, which of course affects how much energy we get. And the third gear is called precession. The best way to picture this is to think of a spinning top. As it starts to slow down, it doesn't just spin perfectly, it starts to wobble, right? Earth does the same thing. It's this slow 26,000-year wobble. And that little wobble is super important because it decides whether our northern hemisphere summer happens when we're closest to the sun or farthest away. And that, as you can imagine, has a huge effect on how hot our summers get. Okay, so you have these three giant gears turning. How do they actually kick off an ice age? Well, it's kind of like a cosmic recipe. It's all about when they line up just right. The key ingredient is a cool summer in the northern hemisphere, because that's where most of the land is. When the cycles align to give us those mild summers, the snow and ice from the winter, it just doesn't melt away completely. And then the next winter comes, and more snow piles on top. And you see where this is going. Year after year, it builds up, and slowly but surely, the planet gets pushed into an ice age. Right now, we're in one of the good times, a warm interglacial period. It started about 11,000 years ago, and honestly, it's the reason human civilization was able to take off. So that leads to the really big question, right? What does the celestial clock say is next for us? Where should we be headed? Well, if you just look at the Milankovitch cycles, if you only listen to that celestial pacemaker, the prediction is clear. We should be starting a long, very slow, very gradual cooling trend, heading towards the next ice age, thousands of years from now. But, and this is a huge but, that's not what's happening at all. And this is where the story takes a sharp turn. Look at this. The natural cycles, our cosmic clock, say we should be getting a tiny bit cooler. But what are we actually seeing? Rapid, unbelievable warming. It's like the planet's natural pacemaker has been completely overridden. Something else is in the driver's seat now. So, another mystery. To figure out what this new driver was, scientists started looking for fingerprints. And they found them in the carbon dioxide that's been building up in our atmosphere. They needed to know, where is all this extra CO2 coming from? So how in the world can you tell where CO2 comes from? Well, it's actually pretty cool. It comes down to a chemical fingerprint. See, not all carbon is the same. There are different flavors of it, called isotopes. And the carbon from, say, a volcano has a totally different isotopic signature than the carbon that comes from burning really, really old plants, fossil fuels. And when scientists looked at the new CO2 in the air, the fingerprint was undeniable. It was fossil fuels. And the sheer scale of this change is just mind-boggling. We've jacked up the amount of this really important climate-regulating gas in our atmosphere by 50%. 50% more than its natural level before the industrial age. You gotta understand, this is a massive shock to the Earth system. We're pumping out CO2 something like 40 times faster than the planet can naturally soak it out through things like the oceans and rocks. It's building up for one simple reason. The planet just can't breathe it in fast enough. We're overwhelming it. And all of this leads to a pretty jaw-dropping conclusion about where our planet is headed. Get this. We have now put so much heat-trapping carbon into the atmosphere that we have, for all intents and purposes, canceled the next ice age. The next one on the schedule? It's not coming. We have literally overridden 100,000-year cycle set by the cosmos. This chart really tells the whole story. Look at it. For hundreds of thousands of years, CO2 levels just danced. They went up, they went down, in this natural rhythm. But they never, ever went above about 300 parts per million. And then, look at the very end. That vertical line, that spike that shoots past 400, that's not a natural cycle. That's us. That's the Industrial Revolution. And this warming we're causing, it kicks off its own chain reactions, these really dangerous feedback loops. Think about it. Bright white ice is like a mirror. It reflects sunlight back into space. But when that ice melts, it exposes the dark ocean or land underneath. And what does dark stuff do? It absorbs heat. So the more ice we melt, the more heat the Earth absorbs, which, you guessed it, melts even more ice. It's a cycle that feeds itself. So here's the bottom line, the really crucial takeaway from all this. For the first time in the history of our planet, the number one thing driving the climate isn't that slow, predictable dance of the planets anymore. It's us, a species, living right here on the surface. We've basically pushed our climate way outside of its natural comfort zone, into a state our planet hasn't seen for millions of years. And that leaves us with maybe the most important question anyone can ask. We've grabbed the controls of the planet's thermostat, so what are we going to do now?